Hello, this is Sean Ashcraft, and this is a video to kind of go over audio loudness using audio loudness meters and things like that. To start off the video, I just want to do a very quick introduction to using loudness meters. And you want to do this whenever you're kind of doing a production. You basically just want to make sure that the loudness of the production is staying consistent, or maybe you're trying to meet a loudness standard. So if you're working in Adobe Audition, working in Multitrack, you can open up the mixer, and what I recommend is putting your loudness meter as the very last thing in the chain on your master fader. So there's a free loudness radar meter that comes with Adobe Audition. I kind of prefer to use this other tool from Melda Production, this loudness analyzer. It just has a few more meters. Something that you want to make sure that you're paying attention to is your target for loudness. And the public radio satellite system uses -24 loudness units relative to full scale. So set your target to that, and then just simply play back your audio. And then we've got a whole bunch of meters on here. The couple that we're really interested in are the peak meters. And using kind of a combination of these middle three meters, and I think the ultimate one to kind of keep an eye on is the integrated meter here. The integrated meter will show you the entire loudness of all the audio that's been playing so far. So if you played back your entire production, it would tell you the integrated loudness of the entire thing. The short-term and momentary are useful for making sure that certain tracks or certain voices are meeting the standard or meeting your target within a certain range. This range meter is actually very useful because it kind of shows you, oh, here's sort of the maximum that your I think it's the short term that it looks at. Here's how the maximum that it usually sits at. Here's kind of the minimum where it usually sits at. It gives you a good idea of, how far you're swinging on either side of your target. So that's a brief introduction to that. You can also use a loudness meter, or I'm sorry, you can actually measure the loudness of audio in the Waveform editor in Adobe Audition. What you want to do is go up to Window and click on Amplitude Statistics, and it'll pull up this module here. You can either scan the entire audio clip, or you can just do a selection. What I would recommend is if you are working on a whole production to go ahead and scan the entire audio file. But you can just take a little slice of your audio. Now you have a lot of stuff here. This will tell you things like, oh, here's where your peak amplitude is in the sample. But down here, this extra field, the ITU loudness, and you might need to adjust, your screen settings to be able to see it. But this is the one we're looking for here. So this will tell you this is the integrated loudness of this particular selection, or if you do the whole file, it'll show you the whole file. So there you go. There's a real quick, let's see here, 3-minute introduction to using loudness meters. Let me dive into a little bit more detail about why we use loudness meters, a little bit more finer detail of actually using them, and a few recommendations from me on meeting your target. And I'm not going to talk too much about the art of mixing, but I'll talk about, a few tips on meeting like a target goal or a loudness standard. So the reason I'm interested in this is because our satellite system, the public radio satellite system, Content Depot, it established a loudness standard a few years ago. And it is -24 loudness units relative to full scale. They have a tolerance, ±2 loudness units, so that's just good to know. You could be at -22, you could be at -26, both would be fine. They also define audio peaks. This is the highest that your audio can peak at, and you notice that the unit there is decibels, full scale. And this is referring to the peak meter that we're used to seeing. So pretty much every DAW that's ever existed will have a peak meter, digital peak meter here. And in the multi-track editor, it's for each track, and it's over here as well. So they're trying to say, oh, don't let your audio peak any higher than this. They also have this, -2 decibels true peak. What is true peak? So this is another reason why I like this meter so much, is that, it has a peak meter, which is nice, very useful. It also has a true peak meter here. And kind of the idea behind using a true peak versus normal peak, I actually picked this audio because I actually have some clipping here. But it kind of shows us this idea of true peak pretty well. So with digital audio, most of us work with digital audio these days, I'd say. And digital audio, despite the fact a waveform looking like a continuous, signal, the truth is digital audio is just a bunch of samples, and samples can only go up to a certain value. But what's really interesting is when you convert from digital audio to analog audio, there's a slight chance that when it gets converted to the analog domain, it can actually go above the value that a digital sample can actually go. Like mathematically, this waveform needs to go above what we can actually digitally sample. I like using the waveform editor because I can zoom out a little bit more. So it's kind of hard to see because it's such a small overshoot. But in theory, between these two digital samples, it'll actually go above 0. So that's why, let me switch back to the session here. That's what true peak tries to account for. It tries to say, okay, in theory, between, these two samples, it might go here. And that is the reason why the loudness standard has a slightly different metric for true peaks than normal peaks. And you also might be wondering, why do they have such a low, usually for peaks, as long as it's not clipping, it's like, who cares? But the public radio satellite system, it feeds a lot of different stations and a lot of different systems. They build into the system just a little bit of this extra headroom, just in case something's not quite calibrated perfectly. So that's kind of the idea there. So what is the deal with all this other stuff? Momentary, short term. I kind of talked about these a little bit, but the truth is with loudness, you can't really have an instantaneous loudness measurement, because an instantaneous measurement of audio would be peak. I mean, that's your instantaneous measurement. But you can have a really fast algorithm to calculate loudness. And so that's what this momentary is. It's just for a very short period of time, it'll tell you where the loudness is sitting at. And it's almost so fast, it's not very useful, because it's rising up and down. It's following how loud like one syllable is. It's not really, it's kind of useful, but it's really not all that useful. Usually most engineers will look at the short-term loudness. Although I will say, you kind of have to be careful, because some loudness meters, let me pull up the loudness radar that's built into Adobe Audition. I think this meter is a momentary meter, because if I go over to settings, it says something about momentary range. I haven't really read the documentation on this, but so this is another reason why I like this free Melda Production loudness analyzer, is that it gives you access to seeing the short-term loudness, which I've read is kind of a more useful loudness meter thing. I think this is over like a second or two. It just gives you a general idea of like how loud you've been. And then with integrated, that's over the entire course of since either the meter started measuring audio, or if you're measuring, like I showed in the waveform editor, if you are either running the meter, that's when it's been going, or the entire loudness of an entire audio file. That's what integrated shows you there. Now, a few quick things here. I'll talk about these in just a second. You can set the different ranges for your meters, for your loudness meters. I generally set mine to EBU +9. And on this free meter over here, I think in momentary range, I can set it to +9. And the reason I use a smaller range is simply because, for the most part, the kind of productions that I work on, we don't have a ton of loudness range. If something's getting 9 loudness units above where your target is, I think it depends a lot on the environment that you're listening, how well of hearing you are. But I think in general, 9 loudness units above a target is kind of loud. And most of my productions are fairly consistent loudness experiences. You know, they're people talking. Even when somebody is whispering something to somebody else, you still want to be able to hear that in like a noisy car or something like that. So on the other end, you know, if stuff's getting 9 loudness units below my target, that's generally a little too quiet. Maybe music will live down here, but if somebody's, you know, if you're trying to follow a conversation and it's swinging back and forth between, you know, one guest is -9 and the other is +9, I mean, that's way, way wrong. That should just sound wrong to you. And I think that's another thing to kind of just keep in mind when you're playing around with loudness units and you're trying to mix using one. Ultimately, it comes down to what does it sound like? But this is a handy tool for working with especially lots of content and long form content. This is just a way to kind of like make sure that, I don't know, it's kind of a sanity check to make sure that, oh yeah, things are staying pretty consistent. So I talked a little bit about range there. This is a pretty tight range because this is just a talk show and everything is kind of compressed anyway. A couple other interesting features of this plugin. It has a metric called PLR and crest factor. PLR, that stands for peak to loudness ratio. And that basically just takes the difference between your peak value and your running loudness. And I think it uses integrated loudness. The crest factor is actually kind of the same thing. In other areas of processing, crest factor is simply the difference between your peak and your average. And I think this one, just telling how fast it's working, I think crest factor is using a combination of peak and maybe momentary or short term to determine its crest factor there. So this is sort of like a fast peak to loudness ratio, whereas this is sort of a slow, here's on average what your peak to loudness ratio has been. So you can see, even though, you know, I've got a pretty narrow range, I've got a pretty wide peak to loudness ratio. So stuff is you know, this audio isn't like super limited. It's still got a pretty wide range of dynamics there. So there's just some stuff there that I hope is helpful. Let me talk a little bit about why is there a difference between a peak meter and a loudness meter anyway? Like what's going on here? Well, this doesn't fully answer the question, but it just gives you an idea that the loudness unit, oh, by the way, I did want to also mention this. So sorry, I'm stepping back a little bit here. This actually says LKFS, not LUFS. This is using actually what's called a K-weighted loudness meter. A K-weighted loudness meter is essentially the same thing as the loudness unit itself. It's just the LKFS was developed first, and then it was made into an international standard through the loudness unit. So there's just like a brief difference there between those two. And they're essentially interchangeable. They might use slightly different implementations. I forget exactly what the difference is, but they're essentially the same. And why do we need to use any of them from the get-go? Well, basically the short answer is humans don't really hear like a peak meter or, you know, like these peak waveforms. We kind of smooth things out. We don't really hear transients the same way that computers do. We also have this interesting phenomenon with our hearing, is that we don't hear low frequencies nearly as well as we hear high frequencies. So just imagine that, you know, somebody is like whistling at you, or, you know, a high frequency scratching or, you know, harsh sound. That'll sound a whole lot louder compared to the same, like this horizontal thing. So like a 70 dB bass tone, you know, we'll hardly be able to hear that. But then compared to a 70 dB, you know, sine tone at 4K, you know, that'll sound a whole lot louder than this bass tone. And it's just because we just don't hear bass frequencies the same way we hear high frequencies. So a loudness meter will try to account for things like this. Now it won't do exactly this equal loudness curve, but it'll do something kind of like it. And another thing it does is it interprets transients and peaks differently than a peak meter does. And the goal with a loudness meter is to kind of emulate how does a human hear audio. And a good generalization, especially for broadcast, for radio, is audiences want to have a consistent listening experience. They don't want to, you go to the movies or you go to a rock concert, stuff is like real quiet and then it gets really loud and rockin', and that creates excitement and energy. But I think when people tune into the radio, they just want to hear people talking and they just want to hear music. And maybe they want to have some dynamic range, but it's not going to be the same as going to, a classical music concert. We're not really broadcasting to replace the concert going experience. We're just bringing that music to the radio. Okay, so that's a little bit about why we use it. Not a thorough explanation there by any means, but that's just a little bit about why. And then let me kind of wrap up by talking about, let's say you need to meet a target or meet a standard, and a few tips about going about doing that. What I generally recommend is that you set your target for whatever, when you're kind of at the mixing and editing and assembly production stage, you kind of set your target to give yourself plenty of headroom. Like, produce the show like you want to produce the show. Don't produce the show thinking, oh, it's got to be loud all the time, or this or that. What I recommend is thinking more in terms of, does my production need to have consistent loudness? What's the range going to be like? And do some tests on your own. Listen to a few different environments, listening to it in speakers or with headphones, maybe some crappy consumer earbuds or something like that, and decide, how much dynamic range do I want? And then go ahead and just work on your production. Maybe have the loudness meter up in the corner just to make sure that you're kind of sort of meeting that goal. But then for the most part, kind of ignore the fact that you have a target. So maybe just set your initial levels, go about doing your production just like you would. And then when all is said and done, start bringing your loudness meter back into the equation and start seeing, am I still meeting my target? Am I way above? Am I way below? Or actually at that point, you've already done your production, determine, okay, I've done my production. Now where do I really need to shoot for? So let's say I mixed at -24 loudness units just so I'd have so much headroom that it's not a big deal. But then I realized, oh crap, I'm actually mixing the sound for web. I've read different places, different targets for what's good for web. And kind of what I typically shoot for is -16 LUFS. And different platforms might adjust this, automatically. But -16 LUFS, that's just kind of what I aim for. And then, maybe go back, and if you have a few moments in your production where you're like way off base, maybe go back and reconsider your mixing. But now what we can do is actually kind of scale it up. And I'm going to flip these around to give a feeling of the signal flow here. So before your loudness meter, one quick and dirty way, like let's say I'm doing pretty well in my consistency, but I'm just way below where my target needs to be. You can throw on a hard limiter right before your loudness meter. And Adobe Audition, its hard limiter is fine. It has a true peak setting, so I recommend switching to that. You can establish on here what your maximum amplitude is, and I would recommend setting it to maybe like -0.1. Just give yourself a tiny amount of headroom to just absolutely guarantee there won't be any clipping on the consumer's end. And then use this input boost here to kind of get your production scaled up to where it needs to be. So I don't have it turned on yet. I'm going to set this input boost to 0, turn this on. And we should be able to see if I boost this up. You see everything kind of moved up there. I can click on these numbers to reset my meter. And you can either eyeball it, or you can try to dial in the exact, thing. But this seems to be doing pretty well. And if you were mixing to -24 and then you need to bring it up to -16, I mean, that difference is just straight up 8 dB. So that should get us there. Now, keep in mind, you do want to listen to this and listen to what happens to your audio, because this input boost may boost your audio so much that now this hard limiter is working a lot to bring your audio peaks down. So if you're listening back to this and you're just like, it sounds a little funny, or, it sounds a little squished, it doesn't sound great, consider putting some more processing before it. But then we start getting into the world of audio engineering and actually, using a compressor, tuning it, things like that. So if you're familiar with that, that workflow and those tools, go ahead and consider using one of those to kind of tame those down before you hit the hard limiter. But for just general production, usually this should be fine. And keeping the constants, look ahead time, release time, you can probably just keep those the same and you'll be probably fine. So that's how you can do it in the multi-track editor. If you're in the waveform editor, so there's a couple things you can do, but keep in mind this. What I was about to say is, like, you can just see what your loudness is. Oh, I'm 3 dB too low from -24. I could scale this up 3 dB if I wanted to. But then the problem is, look at my peak amplitude. I've got no headroom left at all. And in fact, I've actually got, a couple spots where I'm clipping, which is bad. In this case, we can't really just scale it up because we're just going to have more clipping, and then that's definitely going to sound bad. That's why earlier in the multi-track view, I didn't say just gain it up, just turn it up. What you really want to do here is go to Effects Rack and add a hard limiter here. So under Amplitude and Compression, hard limiter, True Peak. Let's say I need this to be -24, and so I'll just bring it up a little bit there. Press Apply. It'll take a second. And then you can see your audio, and it's taking care of these peaks here. It's limited them instead of clipping them. So there's that. There's a few other ways you can do that too. There's in Adobe Audition, there's tons of ways. They have a matched loudness feature that I'm not really going to talk about, but that's a good way of batch processing audio if you need to. And yeah, I think that pretty much covers everything. This is just up at prss.org/loudness. They have lots of documents, they have articles and things. They even have a free tool that you can use to check your audio. If you're using a different program that doesn't support plugins or something weird like that, there's a lot of free tools out there to make sure that you're meeting loudness standards as you need to meet them. So hopefully this was a helpful video that covered a lot of things at just the right amount. Not too many rants or random rambles, even though this is a yet another free form video from Sean Ashcraft. Well, thanks for paying attention and your time, and have a good one.